So had we been in class, I would have done this on the board for you guys. I would have put 2 magnets down and then used a string to do this. Watch what happens. So just those 2 toothpicks and a piece of string makes a perfect ellipse. And that happens because of the definition, which we're going to see on the next page. So the definition of an ellipse is a set of points in a plane, the sum of whose distances, that's represented by the string, from 2 distinct points called the foci, that was represented by the toothpicks, is constant. So that string stays the same all the way around, and it stays the same total distance away from the foci points, which is what makes the ellipse. So let's talk about some terms we're going to see. I'm actually going to go a little bit out of order. Let's talk about the major axis first. The major axis is the longer of the axes. So if it's vertical, it has a vertical major axis. If it's a horizontal ellipse, it has a horizontal major axis. So that's where your major axis is. The center then is the point that's smack dab in the middle there. The vertices are the points on the edge. So these are vertices here. And then the minor axis is going to go the other direction, and it'll be perpendicular to the major axis. That's the minor axis, that's the minor axis. And lastly, the foci would be somewhere in here. They always lie on the major axis, always in the same direction as those vertices. So that's a focus point, and that's a focus point. They should always be inside the ellipse. So then we're going to look at what makes the ellipse go in different directions based on the equation. So remember, I always talk about what's in control. This up here is your rule about what's in control. A squared will always be the larger number. The larger number is what's going to tell you what's in control. Whatever variable has the larger number, that tells you what's in control. So if you look at the first equation, a squared, which would be the larger number, is under the x squared, which is why this is going horizontal, because x is in control. And the second equation, the a squared is with y, which makes it go vertical because y is in control. Okay? Then we have all sorts of information here. The major axis is 2 times a, the minor axis is 2 times b. But to get both of those, you do have to take the square root of the bottom. And then this is going to be a super important formula down here that we're going to use to help us to find the foci. The foci will always be the c distance away from the center, and you can get the c by doing a squared minus b squared. So here is our saying that we're going to say to help us graph these. We start at the center, and then we move the square root of the denominator in the direction of the numerator. If you take the square root of the bottom and move the direction of what the top letter says, that's how you can graph these. So let's start by graphing. If you look at this, the first thing that just pops out at me is the bigger number is here. So that tells me that in this problem, x is in control. And then we can look at each fraction to help us decide where to go. If I take the square root of 36, that's going to be moving left and right because that's where the x is. So that means we're going to go left and right 6. The center for all of these, the start for today, is going to be 0, 0. So we're going to go left 6 from the center, and we're going to go right 6 from the center. And then the next fraction has a y in it, so if I take the square root of 9, we get 3. That tells me, since it's y on top, square root of the denominator in the direction of the numerator, that we're going to go up and down 3. So I'm going to go up 3, put a dot, down 3, put a dot, and then I can graph my ellipse around those points. The last thing we have to be able to do is find the foci. We have to use the formula to do that. So to find the foci, the formula looks a little familiar. It's c squared equals a squared minus b squared. It almost looks like Pythagorean theorem, but is not quite. So it's c squared is equal to, a is always the bigger one, so it's going to be 36 minus 9. Remember, those are already squared on the bottom, so you can just plug them directly in. You get c squared equals 27, and then take the square root, you get c is equal to 3 radical 3. Then to decide how to write the coordinates, you have to remember what was in control. Since x was in control, that's going to control the x part of your coordinate, so it's going to go to the right, radical 3 over 3, and then it's also going to go to the left, radical 3 over 3, comma 0. That's where your foci will end up. To help you graph them, you can type that in your calculator. That's 5.2, so that tells me that I'm going to go over just past 5 and put it down, and then just past 5 and put it down. They should always end up on the major axis and inside of the ellipse. Let's try another one. So in this next one, first thing that pops out at me, I'm thinking about what's in control. This is where the bigger number is. The bigger number for an ellipse tells me what's in control, so I know y is in control. And then I'm starting at 0, 0, and I'm going to move in the direction, square root of the denominator, in the direction of the numerator. So square root of 25 is 5, and because that has an x on top, that means I'm going left and right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then if I take the square root of 49, that's 7. That has y on the top of it, so that tells me I'm going up and down 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I can draw my ellipse. I try and usually draw half of it. I kind of didn't say that on the last one, but I try half of it on one side, and then I go on the other side and draw the other half. I can't do it in one big swoop. It doesn't work very well. So that should be your ellipse. Much better at doing this at Notability. There, that's better. And then we have to find the coordinates for the foci. Again, it's just a formula. It's c squared equals a squared minus b squared. Always make sure you're putting the bigger number first as a squared. So it's going to be 49 minus 25. We get c squared is equal to 24. And take the square root. So then c is going to equal 2 radical 6. This time y is in control. So that's going to end up in the y coordinate. It's going to be 0, 2 radical 6 as one foci. And the other one is 0, negative 2 radical 6. And again, to help you graph it, if you want to put that into your calculator, that is approximately 4.9. So I can go over 0 up 4.9 and over 0 down 4.9. And if you notice, those are on the major axis, the longer one, and they are inside of the ellipse. So this next one, we don't have any fractions, which means we are not allowed to graph it yet. In order to graph them, they need to equal 1 first. So the fact that this doesn't say 1 here, you need to remember that it needs to equal 1 for you to be able to graph it. So your first step here is actually to divide by 144 so we can get that side to be 1. And we can see what these fractions are so we can figure out what's moving where. So then that ends up being x squared over 9 plus y squared over 16 equal to 1. And then we can do the same rules. Square root of the denominator is 9. Move in the direction of the numerator, so that means I'm going left, right, 3. So starting at the origin, left 3, right 3. And then square root of the denominator is 16. We get 4, direction of the numerator, y is in the numerator. So that's going to be up and down 4. 4. And then we can draw our ellipse through there. Try and make it look curvy, not like a football shape so much, but curvy on the ends. And then to find the foci, the formula is c squared equals a squared minus b squared. And this time we get 16 and 9. We get c squared equals 7. And take the square root, so we know c is 7. And based on what's in control right now, which I hadn't talked about yet, that's what determines where that radical 7 is going to go. It's the one that had the bigger number. So y was in control. It also is going vertically, the ellipse. So I know that those have to go in the y position. So it's going to be 0, comma, radical 7 and 0, comma, negative radical 7. And radical 7 is about 2.6. So that's going to be right in here. And that's going to be right in here. Again, on the major axis and inside of the ellipse. The next section is going to have us practice writing out what the equation would look like given information. So there are two things I need you to think about. Is one, based on what's going on in the problem, you need to figure out what's in control. So there's always going to be something that gives you a hint at what is in control. And then the other thing that you need to know is you need to know a and b. You need to know specifically a squared and b squared to be able to write these equations. So reading number 1 says, find the standard form of the equation of an ellipse with a center at the origin and vertices at plus or minus 3, 0 and a foci at plus or minus 2, 0. So if you look at the positioning of both those important points are happening in the x-coordinate, which is telling you x is in control, which is going to help me decide where the bigger number has to go. So I know the bigger number has to go there. But the other thing I need to figure out is what information they're giving me, because I need to know a and b. And based on the information I have right now, this is for the vertices. The vertices always give you a. So that's telling you a is 3. The foci, if you remember, we get the foci from finding c. So that tells you c is 2. So we're going to need to use our formula, c squared equals a squared minus b squared, to figure out what b is, because we're missing b right now. So that's going to be 4 is equal to 9 minus b squared. And when we subtract, it's negative for a second. But then I can just switch that around and make it positive, and we know b squared is 5. And that's really what I need to be able to plug in, so I'm going to leave that as b squared is 5. And then if I go back over here, the other thing I need is a squared. A squared is 9. I'm going to put those together to write my equation. So I'm going to have x squared over something plus y squared over something equals 1. That's just the standard way these are going to look, because these do have centers at the origin, so there's no h and k yet. We'll talk about that tomorrow. But the bigger number needs to be under what's in control, and right now I know x is in control because that's where the points were moving. They were moving on the x-axis. So that 9 has to go there, the bigger number goes there, and 5 would go there. And that's your equation. But you really have to pay attention to what's in control to decide what goes where. So this one's similar. Find the standard form of the equation of ellipse with the center at the origin with vertices at 0, plus or minus 7 and 0, 5. The difference with this one is that these are now in the y position. So y is in control for this particular problem, which is going to tell me where to put the bigger number. And then I still know the vertices give me a, so I know a is 7, that's how far we're moving out to get to the vertices. And the foci, how far we move out to get to those, is c, so I'd be moving out 5 to get to those. So then we just got to use the formula, c squared equals a squared minus b squared. That's 25 equals 49 minus b squared. If I subtract, I get negative 24 equals negative b squared, which means b squared equals 24. So I know b squared is 24. And then I can figure out a squared is 49. And then I've just got to write my equation. I know it's going to start x squared plus something over y squared plus something equals 1. You just have to figure out what number goes where. Because y is in control, the 49 this time, the bigger number is going under y. The 24 will go under x. And that will be my equation. Okay? All right, number 3, they're just giving us different information here. It says, find the standard form of the equation of ellipse with the center at the origin, a major axis with a length of 18 and a minor axis with a length of 12. And then there's a key here. They're telling you the major axis is vertical. that is going to tell you what's in control. Since that's vertical, that tells you y is in control, because that means the ellipse is going to face this direction. So y would be the major axis, and y would be in control. Then we just have to set up the equation for the major axis. The major axis is all the way across, so it's going in both directions, A. So you have to do 2a is equal to 18 to find what a is. A is 9. And then for this minor axis stuff, that's going to tell you that 2b equals 12, that twice moving in both directions is 12, which means b equals 6. And then we really just need to be able to plug in a squared. A squared is 81, and b squared is 36. So then the equation is going to be x squared over something plus y squared over something equals 1. The one that's in control gets the bigger number. So y is going to get the 81, and x is going to get the 36. And that's your equation. Alright, number 4 just mixes it up. It says find the standard form of the equation with an ellipse with a center at the origin. Foci, that's going to give me C. The foci are 6, and then it's giving me the minor axis, which is going to tell me B, 2b equals 10, and b equals 5. And then I just need to figure out what a is here, because they didn't tell me a this time. So if I set up the equation, c squared equals a squared minus b squared, that's going to be 36 equals a squared minus 25, which means a squared is equal to 61, and we can just stop there. I can solve this out. B squared is equal to 25, and then I know the equation is going to be x squared over something plus y squared over something equals 1. But what is in control here? There's a subtle hint, but you had to pay attention to the fact that the foci are moving in the y direction. It'd be over 0 up 6, over 0 down 6. So that means y is in control. So that means that the y is going to get the bigger number. It's going to get 61. This is going to get 25. And that's going to be your answer. So this last one just gives me a little bit different information. It's still giving me the vertices. And just by looking at it at the position of that, I know that x is in control. And I know since I have the vertices give me A. A is going to be 4. Excuse me. But then they gave me a point. Point doesn't give me A, point doesn't give me B. A point comes in the pair x comma y. So that's going to have to play in at some point. So I know the setup is x squared over something plus y squared over something equals 1. And we've got A. If I square it, we've got A squared is 16. And I know x is in control, so the 16 would go here. But I don't know b squared. That's what I'm missing still. I have to use this point and plug in the point to figure out b squared. So if I plug in the point here, 2 squared is going to be 4 over 16, plus negative 3 squared would be 9 over b squared equals 1. And then I have to solve this. So you've got to turn on your algebra. We've got to subtract 4/16 first. That's 9 over b squared is equal to 12 over 16. Or you can reduce that. That reduces to 3/4. And then if I cross multiply, I get 36 equals 3b squared. And divide. That tells me b squared is 12. And then I can go ahead and I can plug that into the equation. So it's going to be x squared over 16 plus y squared over 12 is equal to 1. Okay? So there is one problem for you to try on Class Kick, and then if you could do the homework for tonight so that we can see how this goes, and I will answer questions tomorrow. Hang in there, guys. We're almost to the end of the week.